A very warm welcome to each and every one of you who is listening into this podcast. As I mentioned in the last two podcasts, this is a run up to the roundtable that's being organized in Bangalore at MSRIT on the 26th of July. So far, we have conducted two podcasts. One was with Colonel Valen, the founder of Velina Geosystems. The second one was with the founder of Thorough. It was Vignesh Kandaswamy. Now we have today one of the industry veterans, from the geospatial world who needs no introduction. It's Bobbie Kalra. His organization has been in geospatial transformation all over the world, beginning with North America. Then they have now a firm foothold in UK as well as in Europe. Without any further ado, now I will hand it over to Bobbie. Bobbie, could you please give us a brief overview of your company and the range of geospatial services you offer?
Sure. Thanks, Varad. Thank you for having me over. So Magnasoft has been around for 20 years, plus years. We provide geospatial services in over 72 countries with, our focus really on North America, Europe, and UK. In terms of services, we provide all the way from data capture, data conversion, which is essentially processing, data analytics, and design. If you look at the overall life cycle of the geospatial industry, content and data plays a very big role. So we have been really focused on geo information, and that's where and in terms of verticals, our core verticals are land and infrastructure, land administration infrastructure. Second is utilities. We have done now close to over 1 million transmission distribution corridor mapping. The third is, of course, telecommunications is the fastest growing vertical for us. We provide services in the FTTX, fiber to home, fiber to office space in terms of design and permitting and construction packages just before pre-construction. And the fourth industry, which is sort of emerging for us, is the autonomous and what I call in the consumer space. So 4 verticals, focus on 3 major geographies and 4 service lines.
Great. Thank you so much. Yeah. For the benefit of listeners who are not aware of this term called geospatial transformation, we are all hearing about digital transformation for many years now. Could you demystify what is geospatial transformation, also digital twins, so that it becomes something very interesting for them to listen to and continue?
Yeah. So if you look at the industry, right, and let me start with how the overall geo information has transformed first. Right, from the days of location technologies is nothing new. From the days of Christopher Columbus, it's been there. Had he had a good map, he'd have found India and not found America. But over the period of time, geo information has now grown from just layers of information into databases. Be it a point, line, or polygon can now be read out of databases. It's been over decades now. And geo information is being integrated with mainstream IT, right? Earlier, we used to always do geo analysis on the side. It was being more with the academics and with the universities, and it would take so long to process the data, and then we would try to incorporate that information or use that information to take decisions while running enterprises and large government enterprises. But today, thanks to technology, thanks to the compression technology, where a lot of the spatial data can now be read on mobile phones, thanks to the internet connectivity, thanks to, now we spoke about, talk about Navic, thanks to the technology of really where a GPS or a GNSS receiver used to be so expensive, those 20, 25 years ago, are just now a few cents, which has disrupted the market, thanks to these disruptions, geo information, spatial information is now becoming mainstream, or has become mainstream, right? And now when we talk about geo information or geo transformation, there are organizations that are using uh, spatial information and location as the center of their entire business model, right? Some of the disruption, some of the consumer apps that you see today have already done a lot of, such have taken the lead. For example, if you look at the Ubers, Olas of the world, or the delivery apps today, they really cannot exist without geo-information, right? But when you come to the larger enterprises, right, when you look at a transaction end to end, be it, let's say, a power industry, right? If the whole operations of the power industry has to run, how dependent is it on geo information? What was it earlier, say 10, 15 years ago, and what is it now? So Magnasoft is focused on bringing that geo information into mainstream, making it the epitome of the entire, operational ecosystem, so that all the other operational, parameters can be sort of interlinked or integrated with GIS or geo information being the heart of it, right? And that is what we believe is geospatial transformation, really moving from just in silos to being completely integrated and being able to do a transaction end to end rather than it, being very ad hoc, right? That's number one. Number two, when it comes to digital twins, the world is now moving from 2D to 3D, right? The new avatar is called digital twins. But if you go back to the days of, how paper drawings were converted into CAD, there was a huge, um revolution, I would say, where paper drawings and were converted into 2D and AutoCAD, and all these software had come into play. We are now seeing that happen from 2D to 3D. And 3D, of course, gives you the power to visualize, right? And what exactly are we doing in terms of digital twin? A digital twin is nothing but a replica of a physical asset, right? And when you look at the life cycle of an asset, right from planning, designing, operations and maintenance, up to the end of life of an asset, right? Looking at it from a total cost of ownership of an asset, if that can be replicated in the digital environment, in the synthetic environment, right, and simulate the entire, life cycle of the asset, that to us is called, a digital twin. And the benefits, of course, are plenty, because you can simulate, you can do what if analysis, and then that can help you take decisions when you really start spending your capital on either building that asset and managing that asset, right? So that's what Microsoft focuses on geospatial transformations and digital twins. So
Great. Thank you so much. It was quite helpful. What have been some of the challenges that you've been facing when you try to digitize a city or a country? Because you specialize in that area, right? And that is one part of it, right? First question. The second is that, can you walk us through this process, like how you go about digitizing, what kind of data is gathered? Over to you.
yeah. So let me divide this into two parts. One is on the business side, and then on the technical side, right? On the business side, the challenges that we have been facing, especially with cities, because there are so many agencies that can benefit from a digital twin, right? The question is, who owns it? Which department owns it, right? Whether it is the planning department, or whether it's the electric distribution system or the gas distribution system, because a digital twin can be completely integrated, right? So we've always had challenges in the past of who pays for the data, right? And so the upfront investment is extremely high, because the cost of capture, the cost of creating a digital twin is extremely high, and then maintaining, right? And it's not just meant for one particular discipline. So the challenges that we face with cities is that, who's going to invest on it, who's going to be responsible to maintain and update it, and also in terms of um, you know uh, from an IP perspective as well, right? A lot of data is going to be proprietary to a lot of these agencies and different stakeholders. So those are some of the challenges on the business side that come into play, right? On the technical side, of course, to create a very good quality digital twin. Now, a digital twin broadly can be again in two categories. One can just be a simple mesh model, right, which is a single polygon, a very good looking 3D, a 3D model or a 3D city model. So that can help do analysis to some extent, and you could do little hyper meshes and attach a lot of information to it, attribute information to it. But then you also have the LOD, the level of detail, model, which starts from 1, 2, and some people say 100, 200, and so on and so forth. So the first is, of course, the cost of capturing this information, right? It's not easy to capture the data. How do you collect this information? There are several ways of doing it today. All depends upon the quality of digital twin that you need. We can use aerial imaging. Some of the satellite data is also getting pretty good these days, but aerial imaging, and then you use aerial LiDAR, then you have mobile LiDAR, terrestrial LiDAR, based upon the quality of data that you need, right? So once this data is captured, then you move to processing this data and modeling. And of course, these are very heavy data sets. So how do you sort of manage the large sets of data and then get into the processing piece of it and modeling that? Today, there are a lot of automated tools to do this feature extraction. There are a lot of software available that can do a lot of direct analysis on raw data itself. So depending on the applications, processing, and then the analytics piece is of course the third process, which requires very deep skills. And some of the challenges that come with it is that the domain knowledge is very important for you to extract that information, make sense out of it, right? And the fourth stage is, of course, hosting this data, right, and making sure it's published so that all the stakeholders can access it, on the cloud. So these are the broadly four stages of it, and there are, of course, challenges at every stage of creating, managing, maintaining that, and especially when there is multidisciplinary data coming in. It could be just land data coming in, could be built environment coming in. Then you have the mechanic, the HVACs, the plumbing, the electrical, the fire equipment, a lot of that. Now you can so let me step back. A digital twin can be made for a single pole, like a utility pole, all the way to a city, right? So when you talk about a digital twin, it can sort of be a replica of any asset per se. But when you talk about getting into indoors, and it gets even more complex, because then you're talking about multiple stakeholders trying to integrate and harness this information to take decisions, right? So those are some of the challenges that are both on the technical side and on the commercial side, but the process is the same. Typically, we at Magnasoft look at it differently. When we talk about creating a digital twin, we flip it. We do more of a top to bottom approach, instead of just capturing information, processing it, and then building the tools and hosting it. It's more about what does the client really want. Let's come up with the overall requirements, or what is, let's say, the comprehensive development plan of a city for the next 10, 15, 20 years, right? Convert that into a very comprehensive data model, right? A complete schema of what features do you need to capture, right, for that particular application, or those applications to work. Once the data model is frozen based on the business requirements, right, then we come up with a methodology, for what we call building a source data matrix. In terms of each and every feature, be it a spatial feature or a non-spatial feature or attribute feature, then we define the primary source, the secondary source, the tertiary source, and define the whole methodology of how this data is going to be captured, how it's going to be processed, and then come out with the most optimized way of collecting and processing this information, so it directly goes and sits into that particular data model, right? And it's completely sort of validated at different levels, and make sure that it's fit for purpose. right? So that's the approach that Magnasoft has been taking in creating these digital twins.